So hello everyone, I have just finished the last task in Pset4, which is recover.c. It took me some time, and the explanation of the problem was really making it feel really hard, I guess, for me at least. Brian told us a lot of stuff in the walkthrough, and there was a lot of stuff also explained, but like the part on controlling files and writing to it and reading stuff from it isn't really explained in the lecture, so it was really intimidating kinda, and there was not a lot of videos on YouTube, so I decided to make this video to explain some stuff to you guys. So I'm just gonna walk you through the task basically. So at the beginning you need to make like do I just explain the task, or yeah, let's just walk I will just walk you through the code I wrote. So it was written on the website that we would need a type def unit unassigned int 8t and set that to byte, because a byte is 8 bits. So this would be useful instead of using just an int, because it's a long story. You can write both on a piece of paper and you will get the difference about why we would use byte here. And like volume, like file, like the first problem for the Pset4, I think it was the lab problem, would be really helpful in helping you on reaching the solution for this one. So I did the same thing that we did in volume. I set a constant int. It was previously the header size for the bitmap. This time we will set it as a block size, because a JPEG file reads in blocks like this. Each block of data is 512 bytes. So for each block we will start reading all the information in it, like this, like this, like this. And if we are done from this part, we will go to the next one. If you are done from this part, we will go to the next one. That's basically the problem. So this number will be used a lot in the fread and fwrite, so we made it as a constant, as a global constant. Okay, so that's for that, and we will start with our int main, and we will have a command line arguments, which will be the card.row. So we will do the same things that we did in volume. We will do an argc if statement to check if the user entered only 2 words, which are the file name and the image name and extension, which will be card.row. And if the user entered anything else, like argc would be 3, it will give them this error. And for this one, when we open the the card.row, if the pointer row file is pointing to nothing, this means that we failed in opening the file. because using f open or f close returns a pointer that we can use in our entire file. So we have to make this check when assigning a pointer. Raw file equals null, and if that's true, then we were not able to open the file successfully, so we return 1. This is an important check because it will be asked for in the check 50. Okay, so what I did after that, I wrote the pseudocode that Brian told us about in the ending of the video, and I tried to think about it, think, and walked by it step by step. So first I had to assign a buffer. This buffer will be like a temporary variable, like we used it in the previous problem. Basically we store some values in it. A buffer is like a storage place. We take the values from the first block, do some stuff on it, write to the new JPEG files that we made, and after we are done with this block and we're going to the next one, we empty the data here and we bring the new data. That's what the buffer is for, because we are reading 512 each for each column, so the buffer size would need to be the same size as a block. So we set it as an array, which would be really helpful. That's not like how we did on in volume, because the buffer here was just a variable. Where is it? Yeah, as you can see, because it was just a variable, we had to add this and to address the location that the pointer is pointing at. But we don't need to do that with an array, because the name of the array itself is pointing to the first element. That's what we learned. Okay, so I made the buffer and I made the array size to be block size, which is a global variable which we declared previously. Okay, so we will start writing the main part of the problem. First, I declared here a counter and it equals 0. We will learn why. And declared another pointer, file pointer, because this will be the pointer that points to the new file or new JPEG we will create. It will be helpful later on. So the first thing we need to know, when will the file end? Like, as I said, we will keep moving from block to block to block, but how do we know that we have reached this point? So if we say that we are here now, okay, we are reading here, and the last block will have like this space taken by some data, and this space will be free. Okay, nothing is written in this part of the block. So let's say that this part will equal maybe 200 byte. Okay, and if we return by knowing that this last part will be 200 byte, the fread function returns the block size, which will be 512 in the normal times, but at the last block it will return only 200. So if we found that the block size here is not the same as the block size that is returned by the fread, which is 200 from this side and 512 from this side, we will know that we have reached the end of the file and we have to stop the while loop. Okay, that's how we know the while will stop when we reach this point. Okay, so the while start. We need to know when will we we need to know if we found a JPEG, because mainly the file doesn't start from this block. Like we could have something like this, and we have a block here, block here, block here, but the JPEG starts from only this part. And how would we know not to include this part and only start from this part or this block? The blocks that have the start of the JPEG have the buffer values, as you can see on the screen. The buffer 0 for it will be 0xFF, which is hexadecimal, and 0xD8 and 0xFF, and the force value, which is buffer. Let's clean this. Okay, so buffer three, which is the force value, the force value will be from 0xe0 and 0x. It will be either 0xe0 or 0xe1, 0xe2, and so on until you reach 0xef. So we won't write like 15 boolean value to check if it's one of those values. This will be ridiculous. So what Brian explained, that we will use something called bitwise. What is bitwise operators? He just glanced over it and I had to search for the meaning, and I found some good videos, so I'll just explain it to you. So let's say that 0xe0 is in binary this value. You can find the equivalent from Google. You could just write hexadecimal to binary, or you could convert it using a piece of paper. So that's the first fact we need to know about. And what Brian said is we will do the following. We will have buffer 3, and we will use the bitwise operator, which is this AND. Usually for a logic value we use AND, to compare if this is true and this is true, then that the statement is correct. If this is false and this is true, the statement is incorrect. This is how we used to use and. This is a logical statement, but here we are comparing each binary value for the right side and left side. So if we wrote here 0x(f)(0) and this will equals 0x(0). So what does that mean? If we convert this part and this part and this part to binary, it will really show up. So if we assume that this part will be like 0x(e) and let's say 6, which will be one of the values where the force value of the start of the JPEG, which will be a correct number for it. So we'll say this will be 1 1 1 0 0 1 1 0. Okay, so this is the first part. And now for this one, it will be 1 1 1 1 1 0 0 0 0. Okay, so we will look at this part and this part, this part and this part. If we see for the same position 1 and 1, the output will be 1. If we see 0 and 1, the output will be 0, and so on, because it's AND. Both of them need to be the same value. So by just looking, we have here ones, we have here 3 ones and 0, so we have here no ones. So the resulting value from this will be 1 1 1 0 0 0 0 0. Where did we see this value before? You see, which is also the logical statement we put here. So if we have a value between the range I declared for the buffer force value, which is between 0xe0 and 0xef, we will get this value, which will be equal to this value, which will mean that we got an accurate force value for the JPEG. So that means it's a JPEG. Congratulations. Okay, so if we found that it's a JPEG, we will have count equals 0, which is true. So we don't mind this. I was just testing with some printfs. So if this is true, we will first make a string array of characters. You could say maybe you could make it 100, 50, as you like. It just have to be the same size as this text. If each value of it took 1 byte, maybe if you write 50 here or something, it will work out. Just write any number between 200 and 300 at the beginning and test it out later. So we created this string array. Why? Because we will store the name of the JPEG we will we will create using the sprintf. Sprintf takes a string array, which will you write the name of the file in it. Also, it takes as the name of the file. The formation, I can't remember what was it called, formation value, the percent and then a number or a character. Anywho, %03i will just accept if you enter an integer like 5, it will write it as 005. If you enter 3, it will write it as 003, and so on. That's why we use this part, the 03i .jpeg, and the numbers that we will enter is a count, because I have here each time we enter this part, I will increase the count by 1. So the new file will have, so the file that we created here will be 000, and the next file will be 001. Okay, so we created the name of the file. Okay, now we need to make the actual file, and to make the file we use fopen function. We set the name of the file, which is a string of characters, and the file will be used to write in it. So we write here w here, and here on the left side you have to assign a pointer for it. So you move the data from some place to the address of this pointer. That's why we assigned the pointer outside of the while loop to make it as global value, to use it anywhere in here. I don't know if you do not declare it outside, it does not work for some reason. I need to research for it more, because supposedly pointers can be used anywhere, you know, but I guess you have to declare it outside first. I don't know. Leave it in the comments if you know the answer to this question. If you did it without doing what I did and just declared it inside, just tell me also. Okay, so I opened the file and I named it 000 JPEG. Now we will start writing from the buffer, because we just stored the first block from the buffer. We will use the fwrite. We start writing the data from the buffer in the same size of block, and we will write to image. We will write to image. Image is the pointer we created, and image addresses to the new file. That's how it works. So we started our first file and started writing. This statement will come handy later, but this is if it's not our first JPEG. The statement says if the count is bigger than 0, which will be the next time, because this time the count was 0, and we added here a +1 for the count. So this is basically the main part that we will be using for the whole process. This part is only for the first JPEG only, and each time we add +1 for the count to create a new name for the JPEG file. Okay, so we wrote one block, and we have an else statement here. We move on from it. We will come to the start again. We check the if values here, if statement here, and it's not correct. so no new file. We go to the else. Here we check if the image pointer is not pointing to a null, because if it's pointing to a null, so we didn't enter one of those parts. We didn't enter here, so image was not assigned to anything, and same for here. So if it was pointing to a null, we would not go into this else statement. This is really important. So if image does not equals null, then we are in our second block after opening our first JPEG. So we start writing, and I have a printf here to track everything. Printfs are really helpful, guys, so use it a lot, you know, because it will help you to debug the code faster. So this is the same fwrite function to keep writing this block, and so on. Go to the start, and oh, we found a new JPEG. So we enter here, count is not equal to 0 to go over that, and count is bigger than 0. So we found a new file after our first file. So it's the same process like here, but the only difference is before you open a new file, you have to close the file that you made before. You have to so using the fclose function and pointing to image will close the 000 JPEG we just finished writing to it. Like, this is a resulting image basically. I know, nice. And this is the second JPEG file. Okay, so and so on. We will close the first, the one that we finished writing to it, and open a new file and keep writing and increase the count for our next JPEG if we ever find it. And we skip the else because we opened the new file here, and we go over again, and oops, no new JPEG was found. So we go to the else statement and keep writing, and so on, so until we are finished with our file, until this statement is incorrect. As I explained at the beginning, maybe here will be like 200, and this part will be like 500, still 512, which because it's a constant. Maybe we can check later, create a printf to see what will be the last value for fread. That would be interesting. And before we end the file, you have to fclose the raw file, which is the file that we were reading from, and that's it. All the files are closed. I guess maybe the last JPEG was not closed. Yeah, I guess I need also to set fclose image. Whatever. I guess this was needed. Let's check if it's correct. Make recover. I didn't save. Okay. I guess this part would be really important also. Like, let's run it and see if it make a difference. Oh, you can see the printfs here. I guess it was important for style and I don't know if it will save a memory because we didn't allocate anything, but we have to tidy everything. It might be helpful in the future. Okay, so that's about it, guys. This is recover.c, the last problem in Pset4, and let's head to lecture 5 or week 5. Have a nice day, and leave any question you have in your mind in the comments. And if you have anything to say about my code, something to do better, I would be really grateful if you comment about it to improve my code. And that's about it. Have a nice day and see you in the next video. Bye bye.